because it counts down slow. See, I've been recording for 5 seconds. So that's my first world problem right there. And all right, here we go. Everyone could see. Beautiful. All right, let's look at this together. Because Thursday, we were talking about radians. Okay, radian measures. And I kept saying radian measures, it's related to circumference. Okay, I don't remember if you, how many times I said that, but definitely was mentioning that. Now, what the heck is a unit circle? A unit circle. A unit is just talking about one. It's just talking about one. And if you make this special circle a unit circle that has a radius of 1, right? A unit circle is a circle with a radius of 1. Then you could figure out so many details from it. You could go into, from this one circle, you can figure out all these aspects of different trigonometry. You could find out, you could figure out, pi is the relationship between the circumference and the diameter, or and radius. So the circumference for a unit circle is going to be, our circumference formula, 2 pi r. So we plug in 1 right there, and what do we get? 2 pi times 1. So when you have a radius of 1 for a circle, the circumference is 2 pi. Okay. You see how that works? Because here's our circumference formula. And if you have a radius of 1, which is, the unit circle is always a radius of 1. It's like, what can we figure out if a radius is 1 of a circle? And that's what this whole unit is basically about. Okay. It's kind of like, it starts right now, we're on like step 1, and it's a big stair stepping all the way up. You can figure out so much from it. All right, so look, this is always going to be our initial side. Okay, I'll keep reiterating that as well. So if this is my initial side and I go around the entire circle, I've gone around the circumference of the circle. And remember, when we have 1 as our radius for a circle, the circumference is 2 pi. Okay, so I put it over here, but that's denoting that all the way around the circle is 2 pi when we have a radius of 1. When the radius is 1, all the way around is 2 pi exactly. Okay, and that's going to be really important. So if all the way around is 2 pi, guess how far it is to go from this initial side all the way to this side? It's pi. Okay, and this has to do with, again, the circumference of a circle is 2 pi r with a radius of 1. All the way around is 2 pi, so halfway around is pi. Okay, everyone okay with that? Just mentioning that. Does that kind of, the breakdown make sense? Okay, just kind of stay with me with this, okay? And I'll keep reiterating this, but really we go pi radians. See, these are measurements in radians. All the way around, because it's based on a radius of 1, this is 2 pi radians to go all the way around. This is pi radians to go halfway. Okay, let's keep that in mind. Now, you may still be wondering, well, what is a radian? What is a radian? Remember, a radian has to do with this relationship we're talking about. Okay, so even if you're just remembering, well, I know all the way around the circle is 2 pi radians, you're going to have enough information to do all these problems. When, if we really look at it, pi, remember, is 3.14. So in our homework problems from last Thursday, we had, like we just went over, we reviewed, it had a radian that wasn't like, it wasn't 2 pi over 3. It was like the radian was 0.97, right? So pi is included in our radian measures, but pi is also a number. So to go halfway around the circle is also 3.14 radians. Okay, so it's pi radians. Actually, put this in there. You should have pi radians, 2 pi radians. Okay, it's pi radians or 2 pi radians to go all the way around. But since halfway around is pi radians, guess what? It's also, or 3.14 radians, right? So don't allow the pi symbol in there to be kind of like mystical. Okay, pi is just a number. Okay, but since we're relating in radians to going all the way around the circle is 2 pi, we keep pi as a part of the measurement, but don't let it be like this like magical number. Pi is just 3.14, and to simplify it, So that is halfway around is 3.14 radians. All the way around is 6.28 radians. Okay, and that only works if we have a unit circle. So again, assume always that the radius is 1. All right, now to sketch a radian, today we're just talking about the angles involved with the unit circle. To sketch a radian, first I want to give us an example that has it in degrees. Because degrees, it's a little easier for us to think about, okay? But if I said I need you to sketch 60 degrees, first off, make sure you have this label. This is our initial side. It always starts right here to the right. If this is a coordinate grid, like down here, I show you the coordinate grid. It starts here at 1, 0. That's always our starting point. Okay, guys? So if I needed to sketch from this initial side, I'm going to be creating what's called a terminal side. That's where it opens up to. So it would be, if I opened up this far, so that it was going straight up, and this was my terminal side right here, I would have opened up 90 degrees, right? Or pi over 2. Think about it. This is 90 degrees. It's also in radian measures pi over 2. Why? Because halfway is pi. So 90 degrees going halfway around, a quarter of the way around the circle, so my terminal side would be here. That's pi over 2, because all the way is pi radians, so halfway is pi over 2. We'll get to that. But look here. If I have this in degrees, I'm starting with this initial side. I'm trying to figure out how far do I need to open up. How far do I need to open up to get to 60 degrees? Then I'm going to put my terminal side somewhere in here, okay? Because I look at this, how far is it to go all the way over here to in degrees? This is going from 0 degrees to what? 180 degrees, right? So that's 180 degrees, right? So if I'm really zooming in on this and I'm thinking about it, I'm like, well, if that's 180 degrees, how could I find what 60 degrees is? That's 180. Tell me, what do I need to do in this top portion up here? I need to divide this section into how many sections? If it's 180 to go halfway around and I want to find 60, how many sections do I need to divide this into? Like pieces of a pie. If you have 180 degrees of pizza, I'm going to divide, good, Tavon. I'm going to divide that 180 degrees into how many parts to get 60 degrees? What do you think? You can show me on your fingers. Good. Sadia, perfect. So the way we'll do this is we take 180, which is halfway around, and we're going to divide 180 by 60 and see what we get. 180 divided by 60, we get 3. So what we're looking at here is, if I am looking to see what my angle measure will be for 60, what I can do is I can go ahead and divide this into parts, you see? And then, so this looks like it's 60 plus another 60 is 120 plus another 60 is 180. You see? So we're using this idea that I know halfway around is 180, just like when we get over here to radians, we're going to use the idea that halfway around is pi. But if I'm looking here, my theta of 60 degrees is going to be right here. Okay, and we'll get enough practice for that. We'll get enough practice. I want you to label this side right here. Go ahead and make an arrow to this side. That's called our terminal side. Terminal side. Okay, like you're on a train trip and you end up at a terminal, or terminal means last or ending. Okay, the terminator. I don't know. Term something. So what we just figured out was, we open up this far and we have our 60 degrees, and that is 1/3 of all the way around. Okay. So it actually gets a little bit easier when we deal with radians. It gets a little bit easier. Let's look at this first one. All right. Actually, it's the second one. If I go halfway around, I get all the way to pi. Right? We already figured that out a little bit. So if I go 2/3 pi, How far around do I need to go? Am I going to go past pi? Am I going to go past 1 pi? No, because look what we have. 2/3 pi. 2/3 pi. So to me, what that tells me is I need to go opening up. Instead of going 3/3 pi, 3/3 would be going all the way around. That's 1 pi. I need to go 2/3. I need to go, well, I'll do it this way. I need to go 2/3 about right there. Okay. So what I do anytime I see that the denominator is 3, I'm going to break it into thirds again. And then I'm just going to count it. 1/3 pi radians would be here. I should put that. Sorry, guys. Put radian for both of these. Put radian and radian. Okay. So if I'm doing 2/3 pi, I know halfway around is pi. So I have 1/3 pi. I have 2/3 pi. And that's where I'm going to put my terminal side right here. So this measurement right here, that opening from our initial to our terminal, that theta is 2 pi over 3, or 2/3 pi. You see? It's a different way of measuring. It includes pi, and we're going to even learn later that you have to change your calculator when you go between radians and degrees. But we don't have that yet. Okay? So 2/3 pi is this. Okay? As long as you can remember that halfway around is pi, all the way around is 2 pi, it's a matter of looking to see where the radian fits. And I just realized I wanted to do this the other way around. I'm going to change this. Change number 3, because this is going to be where it gets a little bit different. I want you to put it, instead of 9/11, it's going to be 11/9. 11/9 pi. So go ahead and change that up. All right. So you guys remember when you'd have something like this, you'd have, just a fraction, 11/9, and you had to make it into a whole number with a fraction, like a mixed fraction here. You guys remember this? What do you ask? How many times does 9 go in 11? Once. What's left over? 2/9. Right? Same idea. If this is 11/9 pi, that's equal to 1 and 2/9 pi. Okay, so we're going to use these, trying to figure out to go from an improper fraction to a mixed fraction, because now look at this. What does this say? This is, we have 1 pi plus 2/9 pi, that equals 11 pi, or 11/9 pi. This part's too confusing. Forget that. But we're going to go ahead and keep this idea, though, that 11/9 pi is equal to 1 pi and 2/9 pi. So watch. How far was it again if I went halfway around? Halfway around is 1 pi. And then how much further do I need to go? How many more ninths do I need to go? If I go around all the way to pi, I've gone around 1 pi. But we don't just have 1 pi, we have 1 pi and 2/9 left. You see what I mean? Getting into improper fraction helps me know, okay, it's 1 pi and 2/9 pi. 1 and 2/9 pi. I go around to pi, that's 1 pi. And then I have to go another 2/9. So this is what you do when you have to go another 2/9. It's kind of a bummer. But you got to break this bottom part into 9 parts. You'll get better at it. 1, 2, 3, 4, 5. Just do your best with it. Anytime it's an odd number, I put that at the bottom. I did this one first. and then I had to fit 4 others in the other side, on each side. You see? So I use what I know about improper fractions. 11/9 pi is equal to 1 and 2/9 pi. So watch. I'm going to start at this side. I'm going to go around. Watch me with this. I'm going to go around to pi. And then how many more of these ninths do I need to go? I need to go 2 more. So my terminal side is down here. Right? So here is my angle. And this theta right here, the theta is 11 pi over 9. Whew. You see? I tried to break it down as well as I could. So after you're done with that, give me thumbs up, sideways, down for trying to find these guys. Ooh. It could be thumb sideways. It could be down. Okay, we do a couple more. Let's do a couple extra. No worries. All right. So as you're finishing that one up, I want the next folks to give me. How about this? Let's do this one. Wait. Yeah. Let's do 3 pi over 2. First I look, it's improper, so I know that I can make it into a mixed fraction. And I think we're going to go further than halfway around. Because halfway around, remember, is 1 pi. We have to go a little bit further. So just make a quick circle. It doesn't have to be perfect. We always start with our initial side to the right. Remember, if I go halfway around, it's pi. So change this into our improper fraction. So you say 2 goes into 3. 2 goes into 3 one time. What's left over? 1 half. So we go 1.5 pi around the circle. 1.5 pi around the circle. So I know, look, I know I'm going to go this far because that's 1 pi. I got the 1 out of the way. And then how much further do I need to go? I need to go another half. So this bottom, I'm just going to break into halves. Whoop. Someone got booted and came back. Always come back, guys, if you get booted. All right, I'll let you in. So 3 halves pi, 3 pi over 2 is 1 1/2 pi. I go around 1 entire pi, and then I have to go another half right there. So here is my terminal side. That right there is 3 pi over 2. Okay? And you could look at it different ways. You know, you went 1 half, 2 halves, 3 halves. That's another way to look at it. So, but I think it's best to relate to, well, where is it in relation to 1 pi, which is always straight across half of the way around? Okay, let's do one more. Last one. Let's do, fourths. Let's do 7 pi over 4. Ah, challenge. Challenge accepted. Here's the initial side. Remember, halfway around, based on the circumference of a unit circle, is pi. So where is 7/4 going to be? And who can find a clever way to find this a second way? Who can find it going this way? Don't do it if that totally confuses you, but if you're getting it so far, think about that. How could you measure it this way? So first, let's go ahead and convert this to a mixed fraction. And then if you have your video on and you're done, hold up your graph. Let me check it out. If you're done, try to hold it to the camera. All right, if you're still working over here, actually, I don't think holding the camera is going to work. Never mind. I can't see him. 4 goes into 7 one time. What's left over? 3/4. So it's 1 3/4 pi. 1 3/4 pi. All right, so look, we're going all the way around. We got 1 pi, but we have 3/4 left. Break the bottom part into 3/4. So we have this direction to go around this far is 1 pi, and then we have to go 3/4 further. So we're going to end up with it here. It's all the way around to here. All the way around to there. So that's theta is 7 pi over 4. The way that I was going to ask you how can you go this way? It's because 7 pi over 4, since all the way around is 2 pi, you could have also thought of it as, well, 7 pi over 4 is 1/4 short of going all the way around, so you can go backwards negative pi over 4. If you understand that, you're way ahead. Good job. If you don't, no worries. I'm not going to teach you that way all the way up. All right, give me a thumbs up, sideways, down now. Do we see kind of like better way how to do it? Still sideways? It's fractions. Fractions are usually kind of here, but okay, good. Mostly up. Good. All right, let's see about this. So that's just sketching. Too close. You're sketching the radian measure, okay? Sketching the radian measure. And we went through a couple ways to do it. The last thing we have, since we're just talking about angles today, is the reference angle. All right. So the reference angle is always the angle measure to the x-axis. The angle measure to the x-axis. So remember, the x-axis goes left to right. We're talking about whatever angle measure it takes to get to that. So I'm going to do one. I'll do one right here. What if I had over here, I have, this is my angle, and this theta is 7 pi over 8. Remember, going halfway around is going all the way to pi. So how much further do I have to go for that reference angle? How much further do I need to go to get down to the x-axis? If it's 7 pi over 8, pi is 8 over 8 pi, right? 8 over 8. 8 over 8 is 1. So how much further do I need to go if I'm at 7 pi over 8? How much more do I need to go? 1 what? 1. I have to go this right here, right? I have to go right here. Perfect, Tavon. I have to go pi over 8 more. You see? If it's 7 pi over 8, to get to a full pi, I have to go pi over 8 additional. 1 pi over 8. 1 pi over 8 plus 7 pi over 8 is 8 pi over 8, which is 1 pi. So the reference angle is always asking you how much further you need to rotate to get to your x-axis. Now, if we had one like this, how about this? What if it rotates from here and it goes all the way to here, and we're at 5 pi over 4. 5 pi over 4. Remember, this is pi, which is 4 over 4 pi. So how much, we almost like overshot the x-axis. But the reference angle is always the quickest way that you can get back to the x-axis. Sorry, reference angle is closest direct way to get back to the x-axis. So how much, what is my reference angle going to be for this? What is my reference angle? How much further did we go? We went too far. We went too far. So tell me in the chat, what is the fraction? How much we went too far? How much did we go too far? Good, Santana, perfect. Anyone else want to take a guess? 5 pi, good, Saria, perfect. So 5 pi over 4, if 4 pi over 4 is 1 pi, we've gone pi over 4 too far. So that's going to be our reference angle. You see, you got to just kind of keep in mind the main thing to play with is that halfway around is pi. So you have to kind of like work it from there. It's similar to how we found, and sketched our radian measures. But in this case, we have to kind of use more deductive logic. Now, if you're like, well, is there a shortcut to that? Yeah, there's a cheat. Here's the shortcut. If you have an angle over here in the first quadrant over here, theta is the reference angle. Because if I rotate open, 1/4 pi over 4, right? How far is it to get back to the x-axis? It's to rotate back down, pi over 4. You see? So if you're over here in this space in the first quadrant, whatever your theta is, that is equal. I just put the reference angle is equal to theta, whatever your angle measure is. All right. If you're over in this quadrant, you take pi and you subtract the theta you have, and that's going to be equal to the reference angle. If you're over here, and this is what we did here, it's just kind of like giving you a cheat sheet. You can always count on it. If your terminal angle opens up and it goes all the way over here, it's going to be theta, the angle measurement, minus pi. Okay. And then finally over here, if your angle goes all the way around, theta's way over here, then you're going to go 2 pi minus theta, and that'll give you this little piece left over. Okay. These are cheats. If you like that, if you like kind of putting it in your mind in that way, I don't actually like that. I'm spatial thinking. I like to do this kind of thing where I'm just like, okay, we open up this far, how much further? I like to ask the questions. And I'm teaching you that way, so maybe this idea makes more sense to you. Okay? Just keep going with whatever works for you. Some people really like to just have, well, I'm in this quadrant. I just like to memorize these 4 things and I just subtract it. I'm good. But that's not how I think. So I'm teaching you also like in a way that I think, because that's what I understand the most. That's how I think. All right, let's look for example 4. Let's do this. We have 3 pi over 4. So first, here's our initial side. We need to find where this angle is. And if you want to do this, you have to first figure out where the angle is, but you could find the quadrant and then use your cheat sheet. But let's go ahead and do what we always do. We know right across is pi, because if we rotate halfway, opening it up from our initial side, that's going to be pi radians. But we need to go 3/4 pi. So is the angle going to be somewhere in the top or the bottom of the circle? Give me a finger up, a finger down. Is it going to be in the top or in the bottom? It's 3/4 pi. Good. Sorry, perfect. Good. Yeah. And you have the answer in the chat. That's perfect. What I'm trying to point out is halfway around, remember, is 1 pi. Good. At least you have perfect. So if I have 3 pi over 4, it's not 1 full pi. It's 3/4 of a pi. This is a radian measure. I keep forgetting. Dang it. Put radian right there. Put radian right there, guys. It's a radian measure. Okay. It's not like a quantity. It's how much you're opening up in relation to the circumference. Okay. That's the big thing to get. All right, now watch. If it's 3/4 pi, I know that I can divide the top part into 3/4, right? So if I rotate this far, pi over 4. 2 pi over 4, which is pi over 2. 3 pi over 4, 4 pi over 4, which is 1. But I know that I was looking for 3 pi over 4. So here's my angle right here. This is, theta is 3 pi over 4. And then remember what the question is. It's from the terminal side here. How far is it to get down to the x-axis? So you got to just think about that. Think about it. Rotating halfway around to get to the x-axis is pi. I went 3/4 pi. So my reference angle here is going to be pi over 4. Or you could think of it as 1 pi over 4, but that, well, it would be written like that. But you're mostly going to see, and I'll always say it like this. I'm going to put pi into the fraction. Okay. So the The reference angle for theta of 3 pi over 4, 3 pi over 4 went to here. So to go down to the x-axis, we go another pi over 4, and then we have 4 pi over 4, which is 1 pi. Yep. Thumbs up, sideways down. You seeing it? You like the intuitive way? The intuitive way a little better? I do too. I feel like the intuitive way makes you really understand it. But if you're not like me and you like to use a cheat sheet, maybe this would help. Let's see how that would work. Look, we know it's in this quadrant, right? So watch what we have. Pi minus theta. Theta is 3 pi over 4. Pi minus 3/4 pi is 1/4 pi, pi over 4. You see how it would work out if you had to use that way? Okay. So use the cheat sheet if you like it. It's not quite for me, but that doesn't mean anything at all. That's just my preference. Means nothing. All right. How about this last one? We'll do this one. See where we're at. Okay. So first off, draw your circle. Make your initial side always going to the right. And I like to always put the pi over here because that's halfway around is pi. And I look at 11 pi over 6, and I think, well, that is definitely improper. So let's make it into a mixed fraction here. Good. I see a lot of people working. If you're still not sure about this mixed fraction and converting, you ask, how many times does 6 go into 11? It goes in 1 time. How many is left over? 5. So 11 pi over 6 is 1 and 5 pi over 6, or 1 and 5/6 pi. So look, I know it goes 1 whole pi around. It goes this way. Oh, this should be radian as well. It goes halfway around, and then it has to go a little further. It goes halfway around. That's this part, 1. But then I have to go 5/6 further than 1 pi. I need to go 5/6. So I'm going to do this. I'm going to break it into 6 parts. See? 1, 2, 3. 4, 5, 6. So we have 1 pi. We have, as far as more 6 we got 1 more 6, 2 more 6, 3 6, 4 6, 5 6. So our terminal side is going to be way over here. We went all the way around 1 pi, and then we went 5/6 more pi. So this right here is our theta. That's our theta. So we just figured out where our terminal side is. So remember what this question was asking. It's asking, well, what is this then? And if you did it this way and you have like your pie and all the pieces of the pie, you made your slices, right? It's easier to see what's left over. So tell me in the chat, what is left over? What is our reference angle? Reference angle equals... Perfect. So yeah, perfect. Perfect, Santana. All right, I need one more guess. Give me one more guess for that reference angle. Who else has it? Nice, Dave. That's perfect. And guys, let's write, if we're going to write pi, let's just do pi. That's how you'll see it written out in like a lettering. Okay, pi. So we end up with pi over 6. Because look, to go all the way around is 2 pi. I went 1 and 5/6. So if I add another 1 pi, 1/6 pi here, I get 2 pi. That's why, actually, if we look back over here, look what it is. The cheat for this is 2 pi minus theta. So think about that for a sec. 2 pi is all the way around, right? 2 pi is all the way around. If we minus how far we went, we get how much is left over to go for all the way around. So 2 pi minus theta. That's why that cheat works for that quadrant. Okay. Whew. Let me know in the chat. You want to see one more like this, finding reference angle? Good. Last one, and it won't be microscopic. I'll make it bigger here. All right, find the reference angle for. See, now I don't know how to make a hard one here because we're pretty good at this. Let's do let's do 7 pi over 6. Find the reference angle for 7 pi over 6, if that's my theta. All right, don't look up here if you're doing it on your own. If not, you need help, no worries. That's what I'm here for. Halfway around is 1 pi. 1 pi radian. So if we have 7 pi over 6 radians, then we have to figure out how far around we go first. So let's convert this to a mixed fraction so we could see how far around we go. And yeah, throw your answer in the chat if you have it. I think people probably getting there. Not quite 5/6. Not quite 5/6. Okay. 6 goes into 7. 6 goes into 7 one time. What's left over? 1/6. So 7 pi over 6 is equal to 1 and 1/6. Oops, pi radians. So watch what I'm going to do. I'm going to go around. 1 pi. And then how much further do I need to go? 1/6. You could think of it like this. This 1 pi, 1 is going halfway around, right? And then the 1/6 is how much further you're going to go around. Let's go ahead and look at this. If I'm going 1/6 further around the bottom part, I need to break it into 6. So the reason why we don't break every single, top and bottom into 6 is because I know that I'm going 1 pi around and then another 1/6. So I'm going to end up here. I'm going around 1 pi and 1/6. Here's my terminal edge. So this is theta is 7 pi over 6. Now, how far did I go? Because I want to see how far to get back up to my x-axis, which remember is side to side. So how far? I went too far. I went around 1 and 1/6. So how far back do I need to go? What's the reference angle going to be? You see it now? I want you to put it in the chat. If it just clicked, I want you to put it in the chat. Good, Sonia. Saria, perfect. Anyone else want to take a shot? We're getting close to the end of the time here, so I'm gonna. Good, Alicia, perfect. So look, if I went around 1 and 1/6 pi too far, I need to go back 1/6 pi to get back to the x-axis. So that's my reference angle. We're going to see this over and over, guys. It's not like we're done with this and it's not, everything builds for this unit. So it's important to make sure we get it as much as we can, but we're going to revisit it. It's going to like spiral back. We'll keep using this, and by the end, this will be easier. Okay. So give me a thumbs up, sideways, down. We don't have time to do another unless I do it myself. So tell me in the chat if you want to see me do one real quick. And we'll conclude that way. It's already 3. This class always flies by. I don't know if you feel that way. It does, right? It feels like it goes quick. I don't know how. I really don't. Time flies when you're enjoying it somehow. All right, so we're good. Nobody wants to see another one? We're good? All right, we're good. I'm going to stop the video. That was a 40-minute video. That's a long one. All right, see it. All right, and